All right, thank you. I want to welcome all of y'all to our March 23rd, 2021 Zoom meeting. Um, for those of you who don't know me, my name is Tamara Green. I'm the president of the Astronomy Club of Tulsa. I have been president of the club for several years. I don't remember what year I'm on. I honestly, but then again, I don't remember what I had for dinner last night either. But I want to welcome new members and guests. We're delighted to have you join us this evening. Our members have many wonderful opportunities to share observing with beautiful night sky and make new friends and lasting memories for themselves and families. Plus, there are also opportunities for public outreach to get others interested in our hobby. Excuse me. Please feel free to ask questions, offer suggestions, or volunteer to help out at our events if and when we're able to have them. I'm sure we will someday. All new ideas are welcome, and we're glad you're here. All right. Our members only observing nights return to Friday evenings. Saturday nights will be our backup night for weather cancellations. We are not planning public events until the pandemic subsides. And I'm going to go ahead and take a picture of the screen with my phone real quick. Oh, come on, you stupid. There we go. Because of the pandemic. But hopefully, especially with the vaccines out now, we'll achieve what they're wanting to call herd immunity very shortly. And I'm praying that we are going to be able to get through this and get back to doing public events and get back to normal. Of course, members night is Friday, April the 2nd at the observatory at 7:30 p.m. Again on April the 9th at the observatory at 7:30 p.m. Our Zoom meeting will be on Tuesday, April 20th at 7. Members night will be again on Friday, May the 7th and Friday, May the 14th, both times at the observatory. The 7th will start at 7:45 and the 14th of May will start at 8 o'clock. And the Zoom meeting on Tuesday, May 18th at 7 p.m. Now, here's our guidelines that we have for observing. Set up your equipment at least 6 feet apart. Family groups should remain in their observing area. Children should remain with a family adult at all times. We encourage the wearing of masks, especially with, when with other people. We discourage sharing equipment unless given permission by the owner. Our restroom will be open. Please exercise proper hand washing and sanitizing. The classroom will be open for short warming up periods. Masks must be worn at all times in the building. The domes and other areas of the building are closed. And observing these guidelines will help us continue to enjoy our hobby while keeping ourselves and others safe.
Okay, I'm going to break off here and let Skip talk a minute. If I can get out of screen share. So Skip, are you with us?
Yes, I'm still here. Can you hear me?
Yes, you wanted to
All right.
share a little bit
Good,
about
I-
what's going on at the observatory.
Okay, I successfully unmuted. Let me start sharing here. Share screen. We'll start with this. Share. Now, most of you know that the Astronomy Club of Tulsa has inherited almost 40 acres of land from the owner of the property that our observatory was a lease on. We had a 100-year lease on about an acre of land in what was a much larger parcel. And on this Google Maps image, the observatory building is here. This is the AT&T, that old relic AT&T building with the tower behind it. And the yellow outline is the property outline that we've inherited. There's about a 2.5 acre square of land. It's 350 feet on a side that belongs to a separate owner, the owner of the AT&T property. That is not ours. Now you notice this little gap at the bottom here. There's a discrepancy in the property line description and the title, and several of us are actively working that to find out what we should do about that to basically tidy up our title to the land, and that's an ongoing process. It will probably require some legal work, but we don't yet know. I have a solid estimate of how much money that's going to entail. So at some point, we probably will ask the club for authorization to spend some money on legal fees, but we don't know how much yet. So stay tuned for that. We need to have the membership approval. It's probably going to be enough that we have to have membership approval, but again, that's to be determined. Of this 40 acres, the best part of it is the area from the AT&T property line. Really, this is a hilltop here down there, and that's going to be the primary acres. But it's already probably 4 or 5 times as much area as we've got in the observing field. So this is going to considerably open our opportunities to put up some new equipment and grow the size of our observing field, which is a good thing. We also may change parking situation. Now, one opportunity that has immediately come available that we have decided to accept is we have been offered a 12.5-foot commercially manufactured ash dome for our use by the University of Central Oklahoma, who it was donated to them. They're not going to be able to use it, so they are in turn donating it to us. The dome is currently stored in a disassembled state in Owasso, and I have put together a crew of a gang of 4 to go get it this coming weekend. Once we get it in our possession, it will be stored at James Taggart's home, actually in his workshop just south of Mounds. He's our observatory manager, and he lives a few miles away from the observatory. We will be test assembling it in his workshop to make sure all the pieces are there and they all still fit. Nothing's so damaged that it can't be used. And if that shakes out, it looks like it's usable, then we're going to plan to build an observatory building. And my guess is it's probably going to be somewhere over west of in that area, immediately west of the observatory building. Here's our west fence line on the observing field is here. There's a little oil well here that we need to avoid. And then, but we've got this land over in here that putting up a small external second observatory building could be just dandy. And so what we're going to put in the building is, what I'm suggesting is I'm going to unshare this and share picture. This telescope, this is an Orion Atlas mount and a 6-inch f8 refractor that had been donated to the club several years ago and has really just been sitting in the classroom. And that looks like a good candidate to set up inside that permanent dome, at least to start with. The nice thing about this setup is if we permanently pier mount the Atlas inside the dome, this is a Los Vandy D standard Los Vandy D dovetail, and if somebody wants to use their own instrument on that mount, it's a matter of take this one off, put theirs on, or if we get a different instrument or whatever, we can do that as we see fit. If we like, we could, or if we acquire a better mount, a bigger, better, more good or better mount, we can swap that out for the Atlas. So that expands all kinds of possibilities. This is a nice little instrument. I've been testing it out at home here for the last week or so, and it's really quite nice. It's in pretty good shape. And it's been stored, like I say, for a few years. It was a little dusty and had some cobwebs, but those came off. I'm going to stop sharing here and share. And just as an example of, here is the size of the ash dome that we are going to be getting. This one is considerably newer. It's the same, it's a 12.5-foot diameter, the same size dome as what we have. There's an example of a finished observatory with the dome like that. We currently don't really have anything more than a very vague idea of what we want to do for a structure to support that dome. So I am recruiting people who are architects, engineers, contractors, anybody who, surveyors, anybody who thinks they could make a contribution to this project. I would love to hear from you. And I think this could be a great asset for the club once we get it up and running. And with that, I will turn the meeting back over to John.
Thank you very much. So you're looking for volunteers, huh?
Lots and lots of volunteers. We've got a crew to pick it up unless somebody chickens out on us. My brother and I moved that dome once by ourselves, but we were about 25 years younger. Okay, actually, that's right. We're 20 years younger. But with four of us, it should be no problem at all. What we're going to be looking for is expertise in design and basically constructing of a structurally sound building that will meet our needs.
May I interject? May I interject real quick?
Go ahead.
Before you just start to build, I have a book here. Building a roll-off or domed observatory, and inside it has all the construction techniques and materials for all different types of designs. So this is chock full of information on pierings, footings, what type of structure you want, what type size dome you want, and various aspects. It's a really good book. Happy to loan it, can't give it, happy to loan it to the club if they'd like to go through it.
Thank you, Byron. I will take that and I'll get in touch with you. We are way early in that process, but it's good to have all of these resources available because it's not exactly your standard construction project.
Understand. I was looking to put one in my backyard, maybe in a year or two, but it'll be a roll-off roof.
Well, further down the line, we may want to pick your brains on how that went too, because we may want to do a roll-off in addition, because now we have room to do it.
Okay.
All righty. Well, sounds like we got lots of things to plan on. I'm going to go back to screen share here. If I can get the right button. And that one. Can you see my screen?
Yes.
Just some things that are coming up this summer. The Mid-States Astronomy Conference is going to be Friday, June the 4th to middle of the day, Sunday, June the 6th at the NSU College campus here in Broken Arrows on the east side of Broken Arrow on 101st Street. The Mid-States region, well, you can kind of see there, for some reason, it was half of Oklahoma, but Arkansas, Missouri, Kansas, Nebraska, and so they've been an active group. I've been to several of their conventions. It's a good place to find out what other clubs are doing, to meet guest speakers, And hopefully somebody who knows how to spell the word browse. I see I misspelled it there. But anyway, also, well, I can't get the thing to work here. Hang on a minute. There's the website. It's Misrule.org, and then you can click a link, and it's got all sorts of information about registration. And they got about 2/3 of the guest speakers. There's going to be some kid-friendly seminars or something planned. I don't know clear on what all that is going on there, but the last reflector and the Sky and Telescope magazine were advertising the Astronomical League conference for 2021 in Albuquerque. It was supposed to be in Albuquerque in 2020. Of course, that got canceled. And I was trying to find a link to put on here, but this is the link from the Albuquerque Club, TAAS.org. Anyway, I sent out some emails and I got an answer this morning that they are going to have a convention, but it's going to be virtual again. I had a virtual convention last year. So when I get a little more information on that, I'll put it out in the reflector. But I've been to 2 national conventions, and I got to hear David Levy at one of them. The other one, we got to tour Kitt Peak. That was amazing. But anyway, I'll get you more information on that. But this one's going to be right here in Broken Arrow, so you might want to check that out and registration and such. So let's see. For some reason, my computer is not wanting to do that. There it is. Our guest speaker tonight is Phillip Scott. Phillip will be telling us about his discovery of an exoplanet orbiting a nearby dwarf planet, and a dwarf star. I'll let him explain all of that to you. He's a retired physics and astronomy teacher at McAllister High School, my alma mater, go Buffs. Also, Eastern Oklahoma State College, which is also there in McAllister. And he'll tell us about a group he's been active with. And he was fortunate enough to actually discover an exoplanet using his big Newtonian telescope there. And he'll tell you all about his tracking gears and such. But he's an active member of the Oklahoma City Club and recently won an award there from them. And so I'll get off of here, and the rest of us, well, I'll get off of here if I can figure out how to do it there. The rest of us, let's mute our systems. And if you have questions, let's make a note. Let's not use the chat because it keeps popping up. And, well, I didn't unshare, did I?
Yes,
Hang on a minute.
No, you're good, John. You did good. He can take over now.
Okay. All right, Phillip, we'll let you take over.
Okay, let me see if I can do a share here. Screen 2. I'm still trying to figure out some of this Zoom stuff, so a little bit slow here, but let me get my PowerPoint up. Okay. See my first slide?
Not yet.
Not yet. Okay. Let me see what I've got going here.
Got to click the share screen thing at the bottom. And then click the PowerPoint.
There we go. I think I got it.
Yay.
Okay. Is it there now? Everybody hear me okay?
Yes, I can hear you.
Okay.
Good.
All right. If I'm not loud enough or any other problem you see, stop me and we'll try to get it corrected. But yeah, my name is Phillip Scott. See, as John mentioned, I'm a member of the Oklahoma City Astronomy Club, and I've been in amateur astronomy since 1964. That's when a seventh grade science teacher got me interested in it. So I've been in it a while. And I just recently got into hunting exoplanets, so I'll go into a little bit more detail on that shortly. And but I get started here. There we go. Okay. Yeah, as I said, I got interested in 1964. That same year, I had the opportunity to buy this little telescope, a Tasco 2.4-inch refractor. And that one served me well for quite a few years. In fact, I still have the telescope. I'm not using it currently, but that's not me, by the way. It's one of my students at McAllister High School. We were getting ready. You can barely see a solar eclipse just starting there at the bottom of that image. But as I say, that telescope served me for a number of years. And here's where I do my observing from now. It's a 12 by 24 roll-off building, roll-off roof, and just rolls off half. You just barely see the scope sticking up there on the scope room side. There where I'm standing is that half of the building is my control room, and you know, that's I built this thing as soon as I retired from the high school, and it's very comfortable. I have heat, air conditioning, good lighting, and it is serving me really well. And the only problem I've had with this building is we had I didn't get it rolled back in time before a high wind hit and flipped my roof off. So, but I had it insured and we got it all fixed back up. So I've been a lot more careful about the wind since then. Okay, here's the telescope I'm currently using. This is a 12.5-inch f5 Starliner. And I've had that telescope for over 30 years, but for most of those years it was not a high quality telescope. The mount had a puny little drive on it, was totally inadequate. The optics is good glass in the main mirror, but it was not figured very well, and so my images were really soft. So when I got ready to do my exoplanet hunting, I knew I needed to do some work on that telescope. Inside the control room, here's this is the computer I'm at right now. Dual monitors came in really handy because when I get to going full blast, I have a lot of windows open, and so that dual monitors really helps me to see what's going on. You can see one of my graphs there on the right. That was one of the discovery graphs for this exoplanet that we wrote a paper on and turned in. Currently it's still a candidate. It's waiting on confirmation, for professional confirmation, before they actually list it as a confirmed planet. But I'm confident that will happen. Hopefully, maybe by the end of this summer. But that's still a question mark right there. Okay, one of the things I want to go over tonight is just kind of a quick review of the different methods used for hunting planets, and I know most of you out there are seasoned astronomers, and you're probably familiar with a lot of this already. But in case we have any newbies out there, we'll kind of give you an overview of how planet hunting has evolved. And here's basically the 5 methods that have been utilized to find planets. And of course, the visual planets, who knows, cavemen or somebody way back there in ancient times, realized that some of the stars moved against the background of constellations. And so they called those wandering stars or wandering planets. And so that takes care of that first one. The telescope came along, and then the first planet was discovered using a telescope, and we'll talk about his discovery here in a moment. Even mathematicians have gotten involved, looking at irregularities in the orbit of Uranus. They mathematically figured out where Neptune should be. And then along came photographic plates and blink comparison, and I forgot who it was. Someone had a picture of Clyde Tombaugh on his screen earlier, and of course we know he used this method to find Pluto. Since then, digital imaging has really kind of taken a hold of the field of planet hunting, and including hunting the planets in the Kuiper Belt, and more recently the exoplanets that have been discovered. So that's really what I want to get into specifically, is how exoplanets are discovered, and there's 5 different methods that have been used for those. And there's the first one, radial velocity. This was the first method used, and I'll go over those a little bit more, that one in a little bit more detail here in a moment. But 820 planets as of about the end of the year have been discovered using the radial velocity method. The transit method, where the planetary plane lines up so that the planets pass between us and a star, blocking part of the star's light. This method is called the transit method, and this is by far the most successful method for finding exoplanets. As of the end of the year, over 30,200 exoplanets have been discovered using the transit method. So it's been highly successful, and still is. Direct imaging, a little tougher. We're talking about planets orbiting stars that are many light years away. The close stars, are maybe up towards 100 light years, and many of the exoplanets that have been discovered are much farther than that. So direct imaging is really a tall order, but it has been done, and so far 51 planets as of the end of the year. 51 planets have been discovered using this method. Microlensing, I know very little about this method. I just know that it's a star in the background is magnified by the gravitational field of a foreground object, and so this method, I don't know much about it. It's been more successful than the direct imaging. I've had almost 100 planets have been discovered using the microlensing. Astrometry is the last method, and it's not been very successful. In fact, only 1 planet thus far has been discovered using astrometry. If you stop and think about it, the distance of those stars, many light years away, trying to directly see the wobble in that star due to the gravitational pull of a planet orbiting it, to me, that's a really tall order. I'm not sure which planet it was they discovered using this method, but it is credited with 1 discovery. Okay, now I'm trying to get my slides to advance here. Okay, if we go back to the telescope method, William Herschel in 1781, he discovered Uranus. But what's kind of interesting is he didn't realize he had discovered Uranus at first. And when we look back at his notes in his journal, it was almost a year after the initial discovery that he realized that this might be a planet. At first he thought it was a comet or something else. And in fact, it was a year and a half before he notes in his journal referring to it as my planet. And but once it was announced that it was a new planet being discovered, he became world famous for that. Now I want to note one other thing. William Herschel was an amateur astronomer. Unlike most of the rest of the planets, that were discovered by professionals, William, he was an amateur. Now he was a music teacher by trade. That was his profession, and but he was a very serious amateur astronomer. He built I forget how many, but a bunch of telescopes. He even he cast his own mirrors and using a metal called speculum, and he ground and polished those. He built I don't know, it seemed like it was up towards 100 telescopes. It was an amazing number of telescopes he built. This is his 6.5-inch telescope. This is the one that he discovered Uranus with. Okay, I mentioned mathematicians earlier, and Urbain Le Verrier, a French mathematician, he predicted Neptune in 1846 by observing the irregularities in Uranus's orbit. And then he had an astronomer at the Berlin Observatory to look into coordinates that he predicted. And lo and behold, in just a very short amount of time, he found the planet Neptune, just almost right where Urbain had predicted it. So mathematics is given credit for this discovery. This is my favorite planet discoverer, Clyde Tombaugh, and I got to meet him in 1987 at the Texas Star Party. This man, he had a lot of stories. And we sat around the observing field at some other guys and I had a 24-inch telescope there at Texas that year, and Clyde came and joined us for a good part of the evening. And he spent most of his time telling stories, and he was captivating. And so we really enjoyed him. He was also the featured speaker at the Texas Star Party in 1987. So we had a lot of fun visiting with Clyde. But these are two of the photographic plates that he took. Now he took, I guess, hundreds of plates all through near the equatorial part of the sky where the planets move through, and looking for this planet X, I think is how he referred to it back then. And the method that he used was using a blink comparator, which if you imagine a pair of binoculars with two photographs, focused on each side of the binocular, that's kind of a good description of the blink comparator. You line those images up so that the stars do not move when you blink from one side to the other. And if something does move, then it appears to jump back and forth, making it easier to see. So when I was at McAllister High School, I did a little demonstration for my students, and we set up a demo. And here's an image that I took with the telescope at the high school. And this was the field that Pluto was expected to be in that night. So we processed that image, and then a couple of nights later, I don't remember, it was 2 or 3 nights later, I think it was 2, we took another image. And there's the second image. Now, if you were looking in the right place when I clicked those, you might have seen one object move. And but with the blink comparator, you can blink back and forth as many times as you need. And so I'm going to do that for you now. Watch near the center, and you'll see it jumping back and forth. And so anyway, that would be Pluto. And so my students got a big kick out of doing that, and they helped me with it. So now we move on to exoplanets, and by now we're using digital photography. And the first exoplanet that was discovered was by this man, Michel Mayor. And this planet was orbiting a star in Pegasus called Pegasi 51b is the planet in 1995. Now, he used radial velocity method to discover this one. And radial velocity was using the red shift, blue shift of its spectra to, and what you're actually looking at is the motion of the star, the wobbling. And so that could be seen very easily. And so when it's coming towards you, of course, we'd see a blue shift. Moving away, you'd see a slight red shift. Now, the motion was pretty small. And this method had to wait until the spectrometers had a calibration that was precise enough to measure very low speeds, low velocities. In fact, they now can do this with velocities about the speed of a walking man. So that's pretty low. So so there was a number of radial velocities planets discovered after this time, and it was in 1999 that we have our first transit discovery. Michel Mayor and Jeff Marcy are both credited with this one in 1999. And the transit is when the planet moves between us and the star. So obviously the planetary orbit has to be lined up just right with us. And it's estimated that about 1 out of 100 stars will be lined up in this way, close enough. And so when a planet moves in front of that star, it blocks a portion of the star's light. Even though we cannot see that planet, we can measure that drop in light as it moves across. And we'll create a graph from that, and there's an illustration of a graph below it there that shows the constant brightness of the star until the planet moves in front of it. And we see a slope there until it's completely in between us and the planet and the star. And then when it moves out on the other side, we see the same slope as it goes back up to its normal brightness. Now, this is a simplified version because, as many of you already know, we have, the atmosphere can change the brightness of a star. A star down low toward the horizon is not very bright. When it's overhead, it's much brighter. Also, seeing conditions can change throughout the night, causing a star to dim or brighten as the seeing changes. Thin clouds, whatever. There's multiple things that can cause the brightness to change. So we have to do processing of these curves in order to take out some of these changes due to atmospheric changes or other things that might affect it. In 2018, just 3 years ago, we have our first amateur detection of an exoplanet. KPS-1b, I'm not sure where that one is, but this was a pro-am collaboration. It was between, I don't remember the guy's name now, but it was an amateur astronomer who took the images, and it was professionals at the Ural State Technical University in Russia that did all of the analysis and announced the discovery. Excuse me. But the important thing here is it was an amateur that took all of the images. Well, if we look at the discoveries in a bar graph over, up through 2020 last year, we see there were, the different colors here represent the different methods. The green, which is predominant here, is the transit method. So a almost all of the discoveries have been with the transit method. The red at the top of the bars, those were radial velocity methods, and then we see a sprinkling of the other methods used. I think one thing that's notable about this graph is we have two years there, 2014 and 2016, when there was a tremendous amount of planet conformations. And I think we can attribute that to the fact that the Kepler Space Telescope, which did discovered a lot of transit candidates, NASA dumped this information, for people to then confirm, and looks like they dumped this information in 2 different batches. So we have 2 years there when there were a tremendous number of exoplanets added to the catalogs. Okay, I want to tell you a little bit about how I got interested in this. And my interest first started in the year 2000. That was the first time I'd heard of exoplanets. I had not paid any attention to that before then. My wife and I went to astronomy camp for educators down in Tucson. And it was Don McCarthy, Dr. Don McCarthy, that was heading that camp up. And he did some of the instruction for the camp, and we did a lot of activities and such. It was a really good camp. But one of the things that really stuck out to me was when Don McCarthy talked about exoplanet hunting. And it was just the year before that the first transit discovery had been made. And he made the comment that he thought it was, that entirely probable that amateurs would be observing exoplanets and possibly be discovering planets at some point in the future. That's always stuck in the back of my mind, and so I started paying attention and thinking about how I might be able to do this exoplanet observation. And so gradually I kind of formed a plan, and what I planned to do was when I retired in 2014, I was going to start in earnest putting my observatory together and getting my equipment up to snuff to where I could do this. And so that's what happened. Here's the 12.5-inch Starliner. This was at Okie-Tex Star Party, and back before I built my observatory. And I'd already had the mount worked on. I'm going to go into a little bit of detail about that in a moment, some of the equipment required. And then here's my first exoplanet detection. Now this was a known exoplanet, Qatar 1b, and this was on just August 5th, 2019. That was less than 2 years ago. And come up with a really nice curve on this one. Now, one of the things that really kind of I had to get under my belt before I could really get serious about this was the program used to process this information. And I ran across a program called AstroImage-J, and that's what this graph was made on, and that really kind of opened it up for me. Because really, to tell you the truth, I've been doing astrophotography for a while, and I know there's probably a number of you out there that do astrophotography. And quite frankly, if you're an astrophotographer already, you already have the skills to take the data. And I'll throw out some little details that you need to pay attention to, but taking the data is really kind of the easy part. The processing for me was the tough part, but AstroImage-J made it much simpler than what I had originally thought it was going to be. Shortly after I made that first observation, I got an email from Alberto Caballero. He's an amateur astronomer in Spain, and he put together this group of amateur astronomers around the world. Now, he has a website called the Exoplanets Channel, and he really focuses on detecting and discovering exoplanets. And it was his dream to put together a group of astronomers around the world with the idea of observing a particular star 24/7. It didn't quite work out that way. You didn't have enough amateur astronomers on board, and then things like amateurs having to sign up for time on a telescope, or weather problems, or other issues that came up. We were far short of 24/7 observation. Being retired, I was able to put I jumped into it with everything, and I started observing every clear night, and I have many hundreds of hours of observations tied up in these transits that we've been coming up with, and with a little bit of help from some of the other members of the team and the observations I made, we came up with the discovery last summer of our candidate 3470C. So when Alberto started this group, he had a goal in mind, and he calls it the Habitable Exoplanet Hunting Project. And it was an idea that amateur astronomers to discover potentially habitable exoplanets, and we're looking specifically around non-flare, very cool stars, Gs, Ks, NIMS, and but also within 100 light years. Bringing them close enough to where it makes it a little more probable for amateurs to be able to pick these up. And so I got involved in this a year ago last fall, and we started out observing 9827, which we didn't come up with anything really solid for it at the time. And then when we started in December of 2019, we started observing GJ 3470, a star in Cancer. And my first significant transit occurred on February 27th of 2020. And here's the graph of that one. And you can see the dip in the red line. The blue dots up above, that's the raw data, and even in the raw data you can see the dip in it. But after processing and getting a nice fit on that line, on the red line, we ended up with about 0.5% in depth. That tells us something about the planet's size compared to the star, and a little over an hour in duration. So that gives us kind of a general idea about maybe how fast the orbit is going. And so that was the first one, so we kind of, made note of that and kept observing. And then on May 3rd of 2020, I came up with another one, and it was almost identical, just over an hour in duration and about 0.5% in depth. So I thought, well, okay, we've got something going here. So I looked back at the February transit. There were 66 days between those two. So I knew that the star was about to go out of season, so I knew we're not going to get an opportunity to observe it again 66 days later. So, but I looked back at my data, and sure enough, I had made an observation on December 23rd of 2019. That was 66 days earlier. And so I went back and took a second look at that data, to reprocessed it, and this time I came up with an identical transit again. It was just over an hour in duration and about just over 0.5% in depth. So based on these three observations, we decided to go ahead and submit a paper to arXiv at Cornell University, which offers a preprint service for submissions. And so that's we started really getting noticed after we did that. Now, if this candidate, and I say if this candidate gets the professional confirmation that I'm expecting, This will be the first exoplanet totally discovered by and analyzed by amateurs since the discovery of Uranus, basically. And so that would be quite a deal. But the first step is we got to get that professional confirmation. So just keep your fingers crossed that that's going to happen later this year. So, oh, there's the December 23rd curve. All right. Now, if perhaps I can entice some of you out there to get interested in exoplanet hunting with me. We need more observers. Sometimes I get clouded out, and you guys in Tulsa might be in clear skies up there, or vice versa. So it's would be very helpful if we could get some more people involved in this. And as I said, if you're an amateur or if you're an astrophotographer, you already have the skills to take the data. And I'll show you a few guidelines on how to go about that here in a moment. The first thing I had to do was modify my telescope and the mount. And so this Starliner mount was kind of a cheaply made mount, really. For instance, there were sleeves in the declination axis. Well, that wasn't going to do. I took it to a machinist down at Fort Worth, and he basically rebuilt this mount for me. We put bearings in the declination axis. He built some 12-inch drive gears for me, as you can see one on the deck axis here. And the motors are sidereal technology servo motors. And so I use those and use their programming to run those with. And it's a really sweet system. Here's the polar axis, same 12-inch drive gear. What I want to show you here is this Renishaw sensor. It's an encoder sensor. And then here's the gold-plated encoder tape that's mounted on a 6-inch steel disc, and they have tick marks in those in that tape, and this encoder is able to interpolate extra tick marks in here, and it will count almost 500,000 tick marks in one complete revolution. Well, to break that down, that's about 3 ticks per second. And the importance of this is for periodic error correction. This is the only periodic error correction I have on the telescope. And it's referred to as a closed loop periodic error correction. I don't have to do anything with it. Sidereal technology takes care of it for me. And if it senses a slowdown or a speed up, it instantly takes care of it. So I have extremely good drive on this. So that's the main things I did to the mount. Here's a screenshot of the 2 different programs that I run when I'm taking images. The red screens that's my SBIG control software that I run the camera with. And then the little white screen over here is the drive screen for the sidereal technology servo motors. Okay, on the telescope, I had to do a few things to it. First of all, I wanted a beefier focuser. I put a moonlight focuser on this thing, and so you can see my camera hanging off of it. That's an ST8 and a filter wheel for it. And that moonlight filter allows me to do digital focusing, and it works extremely well. I use that in conjunction with a Batinov mask, and I get perfect focusing. And sometimes if there's much of a temperature change, I might have to focus it maybe once, occasionally twice during the night, to take care of expansion or contraction in a tube. But this focuser works really well. Also, I mentioned that the problems that I had with the mirror It was really soft images. I sent it off to Optic Wave Labs in California, and they do mirror testing. And as expected, they notified me that my mirror could use some serious help. I knew it could, so I told them to go to work on it. It's actually a really good quality glass. It's a Pyrex mirror, and they did a really nice job on it. It's really sharp images on it now. I think, I don't know if there's any mirror grinders out there, but they tell me that this strial ratio is an important number. 1 is perfect, and after grinding and polishing this, my mirror came out to 0.987 strial ratio. So I guess that's really good. That's my assumption anyway. I know it sure gives me great images now. If you're preparing to do an exoplanet observation, there's some important things to do to get ready for that. First of all, you need a good collimation and a polar alignment. You know, those are very helpful if you take care of those ahead of time. My telescope is permanently mounted in the observatory, so polar alignment is easy to take care of, and I collimate every once in a while to try to keep that close. The next thing you need to do is select a target star, and I use a site called it's the Swarthmore College website, and I will list these sites for you on the credits page at the end of this if you want to snap a picture of it if you're interested. But this is a page off of the Swarthmore College website. Now there's others you could use, but I like this one. It's pretty simple. They have these little illustrations on there. Give me an idea at a glance what size of transit I'm looking for. Obviously, if it's my first transit, I wouldn't go for this first one. That one is really tiny. I wouldn't even go for that one now. But a deep transit is pretty easy to pick up in most amateur telescopes. And I use a 12.5, but I think I'm planning to, just to see how well I can do with it. I have a little 80 millimeter refractor, and I'm planning to try to do detection with it. So, and I bet you one like this one I could get. Anyway, the page gives you a lot of pertinent information. It gives you the location, the coordinates for it. Gives you some orbital information. It gives you the timing in Julian date time. Also local observatory time. The brightness of the star, where the moon is in relation to it. It even has some links for other charts, but rather than use their links, I have my own favorite that I'll show you next here. It's this is the example of the chart that I use. In fact, this is GJ3470, and that's the target star in the very center with the crosshairs on it. And so you can set this up to print inverted or reverse it or whatever to match what you see on your scope. Now this chart can be found on the AAVSO site, and it's called the Variable Star Plotter. And you just go into AAVSO and go to their exoplanet observing section, and you can then set this chart up and print that off. And I find it very easy to work with. If you excuse me just for a moment, I need to let the dog out. She's going to start barking if I don't. What happened? Okay, excuse me for that, but my little observatory dog, she loves to come out here with me, but when she's ready to go out, she's ready to go. There's no horsing around about it. Okay, anyway, once you've got your target selected, you can print your target star field, and then you're ready to start doing your observations. Some imaging tips. I've already mentioned polar alignment. It is really important, and because the idea is to try to keep your stars on the same pixels throughout the imaging session if possible. It's not a game breaker if you don't, but it helps if you do. And so here's okay, you can see my guiding graph here. Now, granted, this was on an excellent night. I see no orange or red spikes in it on this night, as I would see on a windy night or a night of bad seeing. This one was totally green, so that's just nearly dadgum near perfect guiding that night. And so that's ideal. And you can see my guide star up here. And I am using a self-guiding camera, and that would be the preferable way of doing it. I started out actually using a piggyback guider, and that works. You know, it's not a game breaker if you have to use a piggyback guider. But on a reflector especially, excuse me, on a reflector, it suffers from flexure, or at least mine sure does. And so you know, through the course of the night, guiding on the same star, you can see considerable movement throughout the night due to flexure in the guider. But if you're using a self-guiding camera, that doesn't happen. And of course, last steps, do your calibration frames. You know, if you're an astrophotographer, you're already doing this, but that just improves your data a little bit more. Okay, here's okay, this is my one of my images, and this is a 60-second exposure of which one is it? Oh, actually, this is not 3470. This is GJ 9827. That was a different one I was observing back in the winter, and or fall rather. And but anyway, I had it in the middle of the crosshairs. That's the ideal place to put it. You can pick a number of comparison stars to use, and you'll need to use several. And obviously, you know, if you're using a German equatorial mount, you're going to have to do a meridian flip at the meridian. You can, if you do that, you can put your target star back on the crosshair. Obviously, your comparison stars are going to move to the opposite side of the star field. But fortunately, AstroImage-J, the processing program, allows you to show where the meridian flip took place, and then it makes corrections to take care of it for you in the final image. So let's move on here. Exposure times. You know, you need to pick an exposure time that keeps you kind of at mid-range on your camera counts. And so, you know, my camera counts are up to, what, about 65,000. So if I get down somewhere around 30, 35,000 mid-range counts, that's excellent. That's in the most linear part of your camera, typically. And a 60-second image of 3470 will put me at about 35,000 counts. So that's just about right. So that's what I typically shoot at, 60 seconds. I can shoot the same star for months at a time, so obviously you need a good hard drive. I have a terabyte hard drive on this computer, and unfortunately, by the end of this year, I'm going to have to start thinking about where I'm going to store my images, because it's filling up. So keep that in mind when you if you start doing much of this. Okay, now I was talking about the program for processing. I'm not going to go into very much of that. It is it's a kind of a long timeline, you know, to learn it, or was for me. It's but there are some good examples you can find online. Now, a man called named Dennis Conti, and he's the observing coordinator for AAVSO for exoplanets, and he does a lot of this, and he has a guide on AAVSO site. This is open to anybody that wants it. You don't have to be a member to use it. So it's called A Practical Guide to Exoplanet Observing, and it is really good. It simplifies it as much as possible. And he also has several good video tutorials on YouTube. He and some other people do. I don't have one yet. I may do one eventually. And but Astro Image J is a very powerful program. But by the way, it is a free download. It's an open source program that has really been handled well. Astro Image J will do about everything you need it to do. Well, for exoplanet hunting, it will do everything you need it to do. It will process, it will plate solve the necessary images. It will add image header information, such as Julian dates, for one thing, or for the air mass index. It will add those to your images, and that helps improve the graphing. It is a steep learning curve, but if you want to get into serious planet hunting, that is my go-to program, and I recommend it. If you're interested in this, at the Okie-Tex Star Party next fall, hopefully we'll get to have that in person. I'm going to be a speaker one night, I think probably on Wednesday night, and to introduce everybody to exoplanet hunting, and hopefully get some people involved in actually taking some data at Okie-Tex. And then we're going to have an afternoon processing session where I'm going to help people, to use this processor to get their curves. So I'm looking forward to that, and encourage you to get involved with that if you want to get serious about this. All right, there's one of the images with the stars selected. There's a target star, and the red circles are for the comparison stars. This other one is a comparison star that was deselected because it probably was a variable, and you'll learn to recognize those after you do this a while. Variable comparison stars will really throw you off. And finally, WASP-12 is an example that's given in Dennis Conti's guidebook. He also provides data so that you can actually do the processing along with the book, and it'll step you through it step at a time. And this is the graph you end up with WASP-12. Now this was obviously done with a much bigger telescope than mine, because I can tell because the error bars are so small. But this is a good opportunity to learn Astro Image J and see it, some real data being processed. Now, what's next? First of all, 3470C is the one that we did the paper on. It needs professional confirmation, and I'm hoping that comes, sometime this year. I'm also working on some others. 3470D, I think I have a good orbital solution for it. E, again, a good orbital solution, and F, good orbital solution for it. So I've got 3 more that look really good. I'm just waiting for them to come around again, and I have it on my calendar when to observe. And once I get those confirming observations, then we'll be ready to submit papers on these planets. Down here at the bottom, well, first of all, G is another one, another possible, but it's a little bit questionable, so I'm not sure if it's going to pan out. And then just 2 nights ago, this was actually 3 nights ago, because this was universal time. This was 34C, the raw data, and you can see a significant flare there. Now, what's significant to me about this is supposedly a non-flaring star, making it possible for habitable exoplanets. This kind of throws a little question mark on that. This was about a 15 or 16% flare, and that is huge. For comparison, our sun, the flares are typically about 1%. So with a flare this big, it makes me kind of wonder if it's possible for there to be a habitable planet or not. A flare this big, for a planet with no magnetic field, it probably would certainly strip the atmospheres away. And even with a magnetic field, it might still have some problem hanging on to their atmospheres. So anyway, that's just something that was totally unexpected from just 3 nights ago. All right. Okay, I'm going to wrap it up now with a video. And there was a guy did a video right after we submitted our paper, and it was the best one I've seen about that summarizes our discovery of 3470C, and also tells a little bit about the Habitable Exoplanet Project. So I'll play that for you, and then we'll take some time for some questions. Okay, I'll leave this screen up for a little bit, but if you're interested in some of these links, you might want to just snap a picture and so that you can look those up later. But that's the end of my presentation, and I guess John, if would y'all like to voice some questions or?
Thank you. I had a question, and then I'll let the rest of the guys get on. 66 days, you said, was the difference?
Yes.
Just kind of mentally in my head, that's about little, the star would rise a little over 4 hours earlier. By the time the next event came around, you had to start real early in the morning and kind of work toward the evening. Is that right?
Yeah, I think I see what you mean. You know, now in December, you know, I've got about probably 6 hours of observing time for 3470, and then probably by February it's up about all night long, and then by May I'm back down to about 4 hours or so of observing time then. So yeah, you know, the stars they come in season once a year. You know, when they're best observed, just like you know, any of the planets you're observing. You know, when they're rising in the east at sundown, you're going to have them up all night, and so that gives you more observing time for those. Now, the 66-day orbit, that's the orbit that we proposed, and but without other observations, you know, that you know, it could be a shorter orbit than that. 66 days was when I saw it, and so I don't know if you know, it could end up being 33 or 22 or whatever.
Yeah.
So that's one reason Sarah Tolola is supposed to, well, I say supposed to, they indicated that they would try to get some radial velocity measurements done on the star this summer. And that would probably, you know, show up as, you know, how many day orbit it is in that, if that's, and it also may, you know, if they do that, they'll probably be able to get some confirmation on some of these other planets that I'm hoping to, you know, confirm for ourselves before we submit a paper. So a lot of that is still kind of open for, you know, for peer review, obviously, and some of the orbital data may change somewhat by the time they get it all figured out.
So do you run on the same star as long as it's observable during the night?
Yeah, as long as there's a reasonable amount of observing time. If there's, you know, and you know, if I get about 4 hours of observing or more, that's good. Ideally, when you're detecting an exoplanet, you like to get about an hour before the transit begins and at least an hour after the transit is done. This is so you can establish some baseline. It makes a more accurate graph for you in the program, but it's not always possible. Sometimes we get partial transits or we get very short baseline data either before or after, and it makes it that sometimes can make the data a little bit more shaky. But so if we get longer exposure times, that helps.
Anybody else out there got questions?
I got one actually. You mentioned the flaring being a potential hazard for Earth-like or habitable planets. You said the average for our sun was about 1%. Is that like for a regular flare, or is that for like the maximum of what our sun can do, like with the flaring?
Well, I think probably an average. and I'm not sure what the maximum would be for the sun. I was discussing this with Alberto, our leader of our group, and he was the one that suggested that the sun's flares are about 1%, and I would have to go back and research that myself to say if that was right or not. But I know that the flare that I measured a few nights ago was about 15 or 16%, and that's, to me, that seems very significant. So that makes me concerned about whether it'd be possible to have a habitable world orbiting this one. Supposedly, 3470C is, if our orbital data is correct, it's pretty much right in the center of the habitable zone. But because it's the size of Saturn, we believe it's probably very unlikely that it could harbor any life with that thick atmosphere. But maybe it has moons that could.
That's what I was about to say. I was going to say, if it's orbiting a gas giant, then the moons could have the protection of the gas giant's magnetic field.
Just like Saturn and Jupiter in our solar system. They're looking at those possibilities.
Mm-hmm. So I still bet money that we're going to find something on either Enceladus or Europa at this point. And the other question I wanted to say is, would you be okay if I mentioned this discovery? I do a planetarium show at the end of each day, and we discuss exoplanet distribution around the sun. I'd love to throw this out there, saying, to tell people, hey, one of these out here was found by a guy right here in Oklahoma. I'd really like to mention that, if that's okay with you.
Yeah, it'd be fine with me. Awesome. Yeah, you just make sure you mention that at least at this time it's a candidate.
Yeah.
It's not a confirmed planet yet, but I'm hoping that will change. Sometime this summer or later this year. So we'll see. There's also a paper. If you're interested, there's a paper on Archive. That's the preprint server that is run by Cornell University. That's where we submitted our paper, and you can find details about it on Archive. Just Google or get on Archive, search for 3470C, and it'll come up. It was July of 2020 when it actually was submitted.
I'll have to read that.
I have a question.
All right.
I take note and absolutely agree with the fact that the observing transits is the preferred and most often used methodology for detecting the exoplanets, and you listed visual, photographic, and another of the other ones, but I'm also aware of another technology, and I'm not wanting to step on your toes or anything, just maybe something I happen to know. One, it's applicable to red dwarfs because it does not work on large bright stars, but on detecting exoplanets or planets orbiting red dwarfs, a method called speckle interferometry is used by using a laser and some mirrors that make an interference pattern and diffuse the star and its brightness so that planets can be actually visibly detected in the fringes of the interference pattern that's created on the star by the speckle interferometer. And the speckle interferometry began in the mid 1960s, and in the 70s was being used to actually see detail on large close stars. It finally evolved into a more suitable purpose, which is this detection of exoplanets. And if anybody's interested in speckle interferometry, it is available if you just simply Google it.
Okay. I have, I've heard of speckle interferometry, and and I understand a little bit about how interferometry works and can see that. It's I guess it's a method of kind of de-brightening the star so that the planets can be. And I was maybe I'm wrong, but I was thinking that as one of the direct imaging methods.
Right,
Uh,
right.
kind of fall into that category is kind of how I would place that. But honestly, I don't know too much about that particular method. But
Yeah.
but
Well,
you're
the
probably
star doesn't look like a star. It looks like a star that's all fragmented up like a globular cluster.
yeah.
That is the closest analogy I can make to it.
Mhm.
And they can tell the fringe of the star, and then any candidate for an exoplanet can be detected just outside the fringe of the star that's being
Yeah.
diffused. Yeah.
Yeah. I know some of the direct imaging methods involved doing some wave interference. Uh, either subtracting the star's own brightness, and it's I don't know. We'd have to get somebody else to explain the details how all that works, but I think that's been used. And I even heard of another direct imaging method that was to image a different star with the almost exact same spectra, and using that one to subtract a star's own light. So it's kind of the same idea. It's wave interference, but with a different star. I've heard of that method being used successfully in some cases. So there's probably the thing about direct imaging, you've got to use some kind of trick, to bring that planet out, because it's just lost in the glare of the star. And the example I used with my students was, trying to see a firefly on the rim of a searchlight that's pointed at you from 20 miles away. It's almost impossible. But if you can somehow remove the light of the searchlight, then the firefly might show up. The other method is if that firefly would pass in front of the searchlight, it's blocking a lot more light than what the firefly produces, and you have a chance of seeing that transit.
Right.
That's what we're doing. I'm currently seeing transits down to about 0.1%, and that's getting pretty close to my limit with this 12.5 inch. If I was to go any lower than that, I would probably need a bigger optics, to do it. But the transit method has been so successful, and it's because of the CCD cameras, the 16-bit cameras that we use these days, they are extremely sensitive to small light changes, and so it makes the transit method very, very doable for amateurs.
Well, you may have other questions, but I want to thank you, and I know the Astronomy Club does too, for your presentation, and a big, big congratulations for your discovery. That's amazing.
Thank you very much. Appreciate that.
Brian, just a little heads up I was thinking about. It's not really a transit, but I looked at astronomy.com a couple of days ago, and it had a little article about a nova that they've discovered on March the 19th. At the time, it was 9.3 magnitude, and they thought it was still brightening. It's a white dwarf star that's drawing in matter from another star. It's not a supernova. It's just in like a big flare up from things falling on it. So, might look at that if you're interested. It ought to be within reach of smaller telescopes.
Well, I just saw something on that this afternoon, in fact, and said small telescopes would be able to see this one, and the indication that I saw was that it is still brightening. So Yeah. Need
Somebody
to,
mentioned it might make 7th magnitude, but put it,
yeah,
within
might
range of suburbs.
be one to check out. Okay, well, if there's anyone out there that's interested in, in taking data, welcome to get a hold of me. My email is listed there at the bottom of the screen, and I'll be glad to help you out all I can, and give you some help if I can. And again, if you want to learn more about the processing program, Astro Image J, there's a lot of information online and on Dennis Conti's website on AAVSO. And I'll be doing a little session on that at the Okie Star Party this fall. So that might be a good way to get started in this. So now, if anybody is interested, I've got a calendar just about filled up with dates
Oh, I don't-
to observe for these transits that I've predicted, and there'll be confirmation observations basically. So I would welcome any help with any of that if anybody is interested in doing it.
Okie starts October 1st this year, is that right?
I believe that date is correct. It's in October. Yeah, I think it starts the 1st and runs through,
9th.
I forget, the 9th or something.
Yeah, starts on Friday this year, so that'll be different. Ends on Saturday.
Oh, yeah. 2 years ago, we ended it on a Saturday because of a snowstorm that came through. Boy, that's the only Okie I've been to that I didn't get to do any observing. Cloudy and rainy all week, and then a snowstorm moved in on Sunday, so they got everybody out of there on Saturday. It was an odd
Yeah, I
loss.
remember. Didn't they have to bring in a grader to pull some of the RVs out?
They did. Yeah, brought a county road grader in. Yeah, some of those big RVs, there wasn't any way they was getting out on their own. It was a mess. It's gonna be much better this year though, I'm sure. And plus the Oklahoma City Club that runs it, they built a new building. So we've got a meeting hall now where we can do all our talks and stuff, be air conditioned. Of course, in October we're going to use the heaters, I'm sure. But it should be nice.